In section 4, we take a closer look at dataset number 2 with the binary outcomes of suicidal ideation and substance abuse. On slide 35, we look at the coverage for suicidal ideation for the 8 time points. And like for the combined data, we have a low attrition over time and have about 84% left at the last time point here. And with good coverage for the covariances between the y's as well. Of course, of particular importance is the coverage for the lower diagonal here, where you look at relationships between the variable and itself at a previous time points. So we've already explained how to read coverage, and I also like to add that we have a similar coverage for the substance abuse variable. Now, the data here is really best portrayed by looking at the response patterns. So here's a list of the 20 most frequent response patterns. So for suicidal ideation, that is the pattern with zeros throughout, that is not having any of these thoughts or behaviors at any of the 8 time points. 155 individuals have that response pattern, which is 21%. For substance abuse, we have 201 individuals, and that's 27%. Now, we also have missing data denoted by asterisk here. And if you look at the bottom, the percentage of those individuals who have zeros or missing is 43% for suicidal ideation and about 54% for substance abuse. So that's a serious challenge for the cross-lagged modeling, because we have close to half of the sample that doesn't show a change, an observed change from 0 to 1 or from 1 to 0 across time, which then makes more difficult the cross-lagged panel modeling. So this is something you want to look at, and effectively here one can think of the sample size as to some extent from one point of view being halved by having that many zeros or missing. Now, of course, we want to fit these response patterns that have the highest frequency quite well, whereas we care less about those with very low frequency. So we're going to take a look at, keep an eye on that as we go forward. On slide 37, we then have the sample correlations for, in this case, suicidal ideation. And that's obtained by the unrestricted all-width model that I discussed earlier, the tetrachoric correlations. In this case, the standard errors for these range from 0.05 to 0.10, so that gives you the precision of these estimates. So you have the correlations here between y2 and y1, and then y3 and y2. So on the lower diagonal here, you see the correlation at adjacent time points with time distance 1. So a fairly low value here in the beginning, and then it stabilizes to values about 0.6 and even 0.7 here at the last time point. For substance abuse, you see a very high correlation between Z2 and Z1, much higher than the rest of the correlations with distance 1. Well, this is pretty high as well. So we could expect the first couple of time points to perhaps be different in the analysis to follow. Now, if you look at the correlations between Y and Z, we can look at them in 2 ways. We can look at them from the point of view of thinking of Y as influencing Z. So then you have Z2, for instance. It's correlated 0.139 with the current Y, Y2, but we're more interested in perhaps how highly it's correlated with Y at the earlier time point. So 0.3 here, very low at the next relationship between Z3 and Y2, But then it goes up to 0.3, 0.5, almost 0.4 across time. It's a fairly healthy correlation across time between those two variables. If you look at it from the other point of view, it's the same correlation matrix, but we just put the red squares differently. Then you act as if Z influences Y. So you can look at Y2, how strongly it related is not only to Z2, but also to previous Z, Z1. So you look at the high values here. 0.12, 0.07, quite low, a little higher here, and then higher for the last 4 cases. Now, that doesn't mean that you have cross-lagged effects that are of this size. Because when you do cross-lag modeling, looking at Z influencing Y, so in this case Z7 influencing Y8, it's not only Z7 that influences Y8, but also Y7. And we're really interested in the conditional relationship between Z7 and Y8, conditional on Y7. So the partial regression coefficient is what we're interested in. On slide 41, we show that what you really want to take an interest in are these conditional relationships between Y and Z. And this is what you get by doing a cross-lag panel model estimation. So for instance, you can look at the this diagonal here, which gives you the effect of Z1 on Y2. So Y2 regressed on Z1, conditional on the Y1, and that is no effect at all between those two time points. Y3 is significantly regressed on Z2, however, positive significant. So is Y5 on Z4 and Y6 on Z5. So that looks fairly hopeful. 3 are significant. For the other way around, regressing Z on Y, you have only one significant effect. That's Z4 regressed on Y3, and the conditional effect. So that looks sobering, and we'll see what happens when we use the full set of models for these data. Now, CLPM modeling may be useful early on to see if there is any hope of finding cross-lagged effects. And if you're interested in RI CLPM cross-lagged effects, they're not expected to be significant unless CLPM estimates are, with the exception of situations with large intraclass correlations, as discussed in Hammaker et al.'s article, where the interclass correlation is the random intercept variance divided by the total variance, and the total variance is the random intercept variance plus residual variance. Now, what about the observed average sample categoric correlations across time? What do they look like? We can sort of infer what the RI CLPM estimates might be, or the magnitude of them. So we have here on the x-axis again time distance in years. We have 8 years, so the first time distance is 1, and then it goes up to 7. So we see then that the red curve is for substance use, and it's higher than the other curve for suicidal ideation. And that's at the end here we see that substance ends higher at about 0.4, although the last time point is unreliable since it only relies on one correlation, whereas there are several of them at earlier stages. Also, so that would indicate a higher random intercept variance for substance abuse than suicidal ideation, and also a higher autocorrelation for substance abuse, starting here with lag 1 at 0.67 or 8. All of these differences may be within sampling variation. So we see a lower asymptote larger than 0, and the random intercept variance is likely, but it will be much smaller than for the stress outcome in the combined data. where these curves at the end were higher.